In this video, we will be having a walkthrough on exercises 6.4. It basically talks about double angle, half angle, and product to sum identities. So these are the formulas that you have to take note of. These are basically clips from the textbook of Mr. John Coburn's Precalculus. Although this video, I'm going to tell this now, it's going to be mostly about double angle identities, the application of these formulas. Apart from that, the rest might not be included in this video, so that's just a heads up. For those who want to learn about double angle identities, this is the right video for you. We'll be answering several practice questions. So yeah, let's start with number 7. So find the exact values for sine 2 theta, cosine 2 theta, and tangent 2 theta using the information given. Okay, so one thing that we have to take note of is the formulas. So sine 2 theta has the formula 2 sine theta cosine theta. For cosine 2 theta, it's basically 1 minus 2 sine raised to 2 theta. For tangent 2 theta, it's basically 2 tangent theta divided by 1 minus tangent raised to 2 theta. So these are the formulas that you have to remember. Although there are certain teachers who will provide these formulas in the exam, you might want to memorize these, especially when you're in college. So first thing that you want to know, you might want to do is to look for cosine theta and tangent theta based on what we have right now. We all know that according to SOHCAHTOA, sine theta is equal to O over H. So right now, it's 5 over 13. Our opposite side is 5. Our hypotenuse is 13. We have to look for the adjacent side. The adjacent side is 13 raised to 2 minus 5 raised to 2, all under the roof of a radical sine. The adjacent is equal to 12. Now, let's look for the cosine theta. Cosine theta is equal to A over H, which is equal to 12 divided by hypotenuse. Tangent theta is equal to O over A, which is equal to 5 over 12. And right now, number 7 is quadrant 2. Based on the satchel or the SATC diagram, in quadrant 2, only sine and cosecant are positive. So sine here is positive, cosine and tangent would be negative. So let's look for the double angle identities of number 7. Let's start with sine 2 theta. So 2 times sine theta is 5 over 13, and cosine theta is negative 12 over 13. Put these values in the calculator and you'll get negative 120 over 169. This is the final answer. For cosine 2 theta, it's basically 1 minus 2 times sine raised to 2 theta. It's basically negative 12 over 13. I'm sorry. It's basically 5 over 13 raised to 2. The answer is 119 over 169. Okay, so tangent 2 theta, it's 2 times tan theta. Tan theta is negative 5 over 12 divided by 1 minus negative 5 over 12 raised to 2. Put all these values in the calculator and you'll get negative 120 over 119. That is the final answer. Okay, so far so good. Things may be quite complicated in a way, but it's pretty simple if you look at it in this perspective. You just have to write down the formulas, apply them based on the current information that you have, and you're good to go. Just use a calculator, it will do the work, and just write down the answers. That's it. For number 8, we're still in quadrant 2. That means only sine and cosecant are positive, particularly on double angle identities. We only involve sine, cosine, and tangent. Maybe that's one certain rule, maybe not. But so far, we only deal with sine, cosine, and tangent. So, cosine theta is equal to a over h, which is equal to negative 21 over 29. What we need to look for is the opposite side. So, opposite is equal to 29 raised to 2 minus 21 raised to 2. We have the opposite side of 20. Now let's look for sine theta. Sine theta is equal to O over H. Opposite side is the 20 and the hypotenuse is 29. Because it's quadrant 2, sine is positive. Let's look for tangent. Tangent theta is O over A. Opposite side is 20 and the adjacent side is 21. This is negative in quadrant 2. So now we have sine and tangent. Let's look for the double angle identities. So for sine 2 theta, we have 2 sine cosine. Okay, so this is the one. Cosine 2 theta it's 1 minus sine raised to 2 theta. For tangent 2 theta, it is 2 tan theta divided by 1 minus tan raised to 2 theta. 2 times sine, which is 20 over 29, times cosine, which is negative 21 over 29. What you get is negative 840 over 841. For cosine 2 theta, it's 1 minus, this time let's use another technique, another equivalent formula of cosine 2 theta. It's basically 2 cos cosine raised to 2 theta minus 1. So 2 over 1 times cosine, which is negative 21 over 29, raise it to 2 and minus 1. What you get is 41 over 841. Okay, so for tangent 2 theta, 2 over 1 times tan theta, which is negative 20 over 21, divided by 1 minus negative 20 over 21 raised to 2. The answer is negative 840 over 41. So that's number 8. Let's move on to number 9. So given cosine theta is equal to negative 9 over 41, cosine theta is negative 9 over 41, which is a over h. You have to look for the opposite side. Opposite side is equal to 41 raised to 2 minus 9 raised to 2, all under a roof of a radical symbol. Opposite side is 40. So let's look for the sine theta. Sine theta is O over h, which is 40 over the hypotenuse, which is 41. We know that in number 9, we are talking about quadrant 2, so only sine and cosecant are positive. So sine here is positive. Let's look for tangent. Tangent is O over A. 40 divided by adjacent, which is 9. So this is negative. Okay, double angle identities. I'll just duplicate them to make it faster. So 2 over 1 times sine theta, which is 40 over 41, times cosine theta, which is negative 9 over 41. We get an answer of negative 720 over 1681. In cosine, we have negative 1519. I'm sorry, I'm already spelling the answers. Here goes. So cosine is negative 9 over 41 raised to 2 and minus 1. We get negative 1519 over 1681. For tangent, we have 2 over 1 times negative 40 over 9 over 1 minus negative 40 over 9 raised to 2. Here, we get 720 over 1519. So that is number 9. Number 10. This time we're in quadrant 3, so only tangent and cotangent are positive. Let's recall SATC diagram. This is tangent, that's quadrant 3. Only tan and cotangent are positive. So we have sine theta, which is negative 63 over 65, which is equal to O over H. Adjacent is equal to 65 raised to 2 minus 63 raised to 2. Adjacent is 16. So let's look for the cosine theta, which is A over H, which is 16 over hypotenuse, which is 65. That's negative. Tan theta is equal to O over A, which is equal to 63 over adjacent, which is 16. Tangent is positive because in quadrant 3, it's positive. Cosine is negative, on the other hand, as well as sine, as you can see here. So, again, copy paste. Okay, this time, 2 over 1 times sine theta, which is negative 63 over 65, times cosine theta, which is negative 16 over 65. The answer is 2016 over 4225. Okay, for cosine 2 theta, 2 over 1 times negative 16 over 65 raised to 2 minus 1. The answer for that is negative 3,713 over 4,225. For tangent 2 theta, we have 2 over 1 times tangent theta, which is 63 over 16, and over 1 minus 63 over 16 raised to 2. We have negative 2016 over 3,713. That's number 10. Let's move to number 11. So in quadrant 3, again, only tangent and cotangent are positive. As you can see here, the fraction is positive. So let's look for the hypotenuse. That's the missing value. The hypotenuse is 85. And so, given that, let's look for the sine, which is O over H, which is 13 over 85, which is negative. Since in quadrant 3, everything except tangent and cotangent are negative. So cosine theta is equal to A over H, which is 84 over 85. And put negative. There you go. Again, copy paste. Okay, so 2 times sine theta, which is negative 13 over 85, times cosine theta, which is negative 84 over 85. We get, 2,184 over 7,225. And for cosine 2 theta, we have 2 over 1 times negative 84 over 85 raised to 2, then minus 1. We have 6,887 over 7,225. That's the final answer. 2 over 1 times tangent theta. Tangent theta is 13 over 84 over 1 minus 13 over 84 raised to 2. Put those values in the calculator and we get 2,184 over 6,887. Alright, we have our last number. I might conclude the video here. Yeah, this is the last question that we'll be answering in this video. This is going to be also the last for exercise 6.4. This is everything that I could salvage answering. So given there, right now we no longer involve sine, cosine, tangent. This time we have secant, the inverse of cosine. So if secant is like this, then therefore cosine is basically the inverse. So reciprocate the fraction. So right now we have A over H. Let's look for the opposite side. We have 45. So right now, let's look for the sine theta. Sine theta is O over H, which is opposite side over hypotenuse, which is 53. And right now, we're in quadrant 1, so everything is positive. Sine is positive, secant is positive, cosine is positive, and for tangent, it will be positive. O over A, O over A positive. There you go. So now, let's use the double angle identities. Two over 1 times sine theta, which is 45 over 53, times cosine, which is 28 over 53. We have an answer of 2,520 over 2,809. Cosine 2 theta, we have 2 over 1 times 28 over 53 raised to 2 minus 1. So the answer is negative 1241 over 2809. So tan 2 theta, we have 2 over 1 times 45 over 28 divided by 1 minus 45 over 28 raised to 2. We get an answer of negative 2520 over 1241. So that's number 12. Okay, that's it. I won't be answering number 13 and everything else over here. I really don't have the time and resources to answer all these. My time is limited. It's already the second part of my first semester, and yeah, I barely have any time to do this. But let's talk about number 17. Only number 17. The rest, no. Find the exact values for sine theta, cosine theta, and tangent theta using the information given. So, managed to find a way in number 17 hang on. Okay, never mind. I can't teach this. I'm not sure about this one. But I've checked the answers, they're all correct. I won't be able to discuss this anymore. But yeah, somehow I hope the video helps, particularly in the ones that I've taught you just now. From numbers 7 to 12. They're basically practice questions involving the double angle identities. Next video will be about 6.5. Be sure to watch it also if you want. Thank you for watching.